Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Adni binti Abdullah, number matrix 210319, and
I am Izzati Rahmi binti Dawud, and my matric number is 212800.
so today we'll be presenting question number 1 from SCL. So the question was like this: the area of a sphere is increasing at the rate of 18 cm squared per second. Calculate the area of increase of the volume of sphere at the instant where the radius of the sphere is 8 cm. So based on the question, we actually can get the new info. We can have the extra information. For example, it states here the rate of area is 18 cm squared per second, and also it also given the radius of the sphere, which is 8 cm. So the main things that we need to solve in this question is that they ask us to calculate the rate of increase of the volume of the sphere when the radius of the sphere is 8 cm. So the first thing, the first important thing is that whenever we want to solve any mathematics questions, is we need to list all of the information that have been given based on the questions. So like I just said just now, the information that have been given in the question was the rate of area, which is 18 cm squared per second, and also radius of sphere, which is 8 cm. So these pictures, this image of sphere is so that we can get the imagination when solving these questions. So it will help actually. Okay, so we'll be moving to the first step of this question. The step 1 is that we need to differentiate volume of sphere. Even though the volume of sphere didn't given out on the question, but we all know that it is a basic equation, which is 4/3 pi r cubed. So first thing is that we need to differentiate. When we differentiate the volume, we will have 4 pi r squared. Okay, why we need to differentiate? Because we'll be using this equation, this differentiate on step 3 and step 4 that will be explained by my friends. So we'll be moving to the step 2, which is we need to differentiate surface of area of sphere. The same things that we did on step 1, which is we need to differentiate. So the area of sphere, it is the basic equation that we all must know, which is equal to 4 pi r squared. So when we differentiate, we will have 8 pi r. So I'll be passing step 3 and step 4 to be explained by my friend, which is Izzati.
Okay. From the question, we need to find the rate of change dv over dt of the sphere. So the formula of dv over dt is dv over dr times dr over dt. So from the question, we didn't get the information of dr over dt. So first of all, we need to find first dr over dt from the chain rule of dA over dt, which is in step 3. Okay. From the step 3, we can see the formula is dA over dt is equal to dA over dr times dr over dt. So from this chain rule, we can get the dr over dt as dA over dt is we get from the equation, which is 18. dA over dr is we get from the step 2, which is 8 pi r times dr over dt. So from using the chain rule, we can get the dr over dt, which is 8 pi r over 18. So we can simplify it, and it will become 9/4 pi r. Okay, then we can use the dr over dt into this formula, which is dv over dt equals to dv over dr times dr over dt. So dv dr is actually we get from the step 1, which is 4 pi r squared, and times dr over dt, which is we get from step 3, which is 9/4 pi r. So when we multiply this, we will get 9r. So as the question asks us to find the volume, the rate of volume when r equals to 8 cm, so we need to substitute r with 8. So when we substitute it, we'll get 72 cm squared per second. So the rate of change in volume of sphere is 72 cm squared per second. So that's all for us. Thank you.
Hi, my name is Nur Alia Amira binti Muhammad Ikram. My matrix number 211366.
My name is Nur Aini Syahidah binti Abdul Rahman. My matric number is 211146. The other day, I have asked Alia about question number 2 from SCI question. But I don't really understand what we need to find from that question. Can you help me, Alia?
Yes, sure.
This question.
Okay. So firstly, we just have to read the question first. So I read it first. Water is dripping out from a container having the shape of an inverted cone at the rate of 0.8 cm cubed per second. If the radius of the base of the cone is 12 cm and its height is 18 cm, find the rate of decrease of the height of the water level at the instant when the height of the water level is 6 cm. So basically, you understand what the question is talk about?
From the question, I know that dripping out is we need to use negative because the water drip out, the water level decrease, right?
Yes.
And what is rate of decrease of the height of the water level?
Okay, so that is what we have to find. So it tells us about rate of decrease of the height of the water level. So firstly, let's see what they give us, the keyword. So first we have rate of 0.8 cm cube per second. So what do you think it is about?
I think there is the rate of water level
Volume.
volume because the cm cube.
Yes. If we don't know what is the terms, what is the value, we just see the unit. So the unit is cm cube per second. So basically we have the dV/dt for 0.8.
dt stands for rate, right?
Yes. So next keyword is radius of the base.
This one.
They give us 12 cm as at the graphic, and its height is 18 cm. So the question is rate of decrease of the height of the water level. So it means that we have to find the dH/dt because dH is about height and dt is rate itself.
Okay. And when do we need to substitute cm this cm?
Okay, so basically, if they give us the height of the water level is 6 cm, so that means that we have to make sure our equation, our terms is in terms of height itself because we don't have its radius. So we have to find the terms in terms of h.
You mean
Basically, it is easier.
You mean the radius of this part? You mean
Yes.
the
Yes.
So this one. So this one the given keyword, right? dV/dt
Yes.
R H N.
So basically, you just have to highlight the keyword or just type like this so that we can easily know what we have. Yes.
What is this?
So what they give us is about dV and dVdt, and they want us to find dHdt. So we are looking for the dHdt of water. So based on the formula of chain rule, we have dV per dt equal to dV per dH times dH per dt.
So if we want to find dH per dt, we need to move dV over dH to the left hand side.
Yes.
So it will be
So
dH
that,
per dt equal to dV per dt times dH per dV.
yes.
So I see. Then next.
So the first step is, it tells us since we want dH per dt, so we have to make sure our equation is in terms of H. So like I say just now, we have the formula of volume of cone. At the next slide, yes. So we have here the variable of r, which is radius, and height. So to get the dV per dr or dV per dH, we have to make sure we have only one variable on the formula, in the formula. So what do you think? We have to get the dV per dr or dV per dH?
Based on this equation, we need to have dV over dH.
So to make
So
sure
we
that we got the dV per dH after differentiate, what we have to do?
find R
Using the,
using ratio.
yes, correct. So
How do we get 12 over 18 equal to R over H?
so 12 and 18 is from the big cone, from the container, and the right hand side is from the shape of the water level itself.
Oh, because water follow the container of the shape, right?
Yes.
Shape of the container. So we got R here and substitute into the formula volume. Then differentiate, we got dV over dH equal to 4 over 9 pi H squared, right?
Correct.
Then
So
substitute
next,
into the chain rule.
so what do you think? Why we have to substitute dV per dt with negative 0.8?
Based on the question, it says dripping out, means that the water level decrease. So it gives us the given keyword was dV over dt is 0.8. Since it's dripping out, so dV per dt is equal to negative 0.8, right?
Yes.
Okay. Then substitute everything. We get dH over dt is equal to negative 9.5 over 5 pi H squared. Last step.
So for the last step, we just have to substitute the value of the height as given from the question, which is 6 cm. So make sure we substitute. Or another method is we substitute directly when we got the
This one.
we just substitute directly the value of H itself.
Here.
Yes.
So we just need to leave the question with negative because it see the rate of water level described. I see. Now I understand. Thank you, Alia.
All right. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So we will continue to explain about question number 7. It's me, Hamida Abdullah. with matrix number 210431 with Hidayah and Atira. So the question is a 5-meter long ladder leaning against a vertical wall. The bottom of the ladder is pulled along the ground away from the wall at a rate of 0.3 meter per second. So they ask us to find the rate of the top of the ladder will be falling at the instant when the bottom of the ladder is 2.7 meter away from the wall. So from the question, we can get the info which is it is 5-meter ladder and the and next the bottom of the ladder is put along the ground with the rate 0.3 meter per second. So we can conclude it is the ds over dt which is 0.3 meter per second. So they asked us to find the rate of the top of the ladder will be falling. So which means dh dt at the ladder. So they asked us to find the rate of the top of ladder will be falling which is dh dt at s which is 2.7 meters. So I will pass to Atira to explain more about this question.
Okay, thank you, Hamidah. My name is Atira binti Mashukri. My metric number is 212320. So I will continue our presentation, our discussion. So before we find the value of dh over ds, we need to find the value of h first. So we can find value of h by using Pythagoras theorem. So it will be h equal to square root 5 square minus s square. Why we need to use minus? Because in this situation, we need to find the value of another side, not to find the hypotenuse. It will be plus if we find the value of hypotenuse. So using the value of h, we need to differentiate h to get the dh over ds to because we need to use in another formula lah. Next formula. So dh over ds will be 1 over 2 bracket 25 minus s square power of negative 1 over 2 multiply with negative 2s. So after we simplify it, we get negative s over square root 25 minus s square. So I will pass to Jaya.
Thank you, Atira. So my name is Nurul Hidayah binti Mu'fazil and my metric number is 210455. For the last steps, so I will explain how to get dh over dt. So by using chain rule, by using the formula of chain rule, we know that since we have dh over ds and also ds over dt, so we just times dh over ds and ds over dt to get dh over dt, which is the question that they want. So just by using the dh over ds last answer, we just times with 0.3, which is the question given, and we'll get 2.7, negative 2.7 over square root 25 minus 2.7 square times with 0.3, and the last answer will get negative 0.1925 meter per second. So the rate of the top of the ladder will be negative 0.1925, which is will be less than the rate of the bottom of the ladder. So that's all for us from us. Thank you.